Hello everyone, welcome back to Electronics Prepper, the channel where we try to learn as much as possible about electronics to become more self-reliant with technology and prepare for the future. Today I would like to discuss a little bit about microcontrollers. More precisely, I would like to present to you a comparison of the most popular microcontrollers out there on the market that many people like to use in various projects, because I honestly didn't saw this particular kind of video, this particular kind of information that I want to present anywhere else on YouTube. And the informations that I needed, the informations that I will present to you were something that I needed myself. I'm not a big fan of microcontrollers in general, but I have to admit that they do have some advantages, and sometimes it is impossible to work on a project without actually using a microcontroller board. Whether it's some Arduino, Raspberry, or otherwise, like a Nat Tiny board or microcontroller. Typically, when we want to design and build custom measurement devices or testing devices, we will probably need to use a microcontroller, for the simple fact that we will most likely want to use some form of display to, show us some meaningful information on screen, and that will be impossible to be achieved without a microcontroller board. So I will show you informations about the most popular microcontroller boards, some tests that I did to basically determine which one is better than the other ones, and some conclusions I drew. And it's quite a bit of data to show you, so stick around. Before we get into the nitty-gritty details of this video, please allow me to thank the sponsor of this video, which is PCBWay. And I would like to also give you some good news. PCBWay are currently organizing their 6th project design contest, and you can participate too. They have 2 themes this year. As you can see here, you can either choose to create an electronic project or a mechanical one, such as a 3D printed project or CNC machined one. You can apply and upload the necessary files until 15 January 2024. And if you're one of the lucky winners, you will find that on 8 March 2024. You can find all the details and the rules on the contest webpage. And also, if you need help with the building of your project, whether it's a PCB with assembly of components, 3D printing, or injection molding, or CNC machining for a mechanical 3D device, you can definitely use PCB manufacturing services from PCBWay. You can check their main website. I will put both links in the description, so you can definitely increase your chances of building something cool, having your project to be found interesting by others, and eventually winning something nice. So both links are in the description. Thank you very much, PCBWay, for sponsoring this video. Good luck with the contest if you choose to participate, and now let's get started with the informations that I would like to show you. So, I chose one piece of I would say every microcontroller board that is popular right now on the market, almost one of each, and also one that is not so popular, but it was relatively easy for me to get it because it's manufactured in my country, and so buying this board is easy. And I also chose to put it on the list because the price is competitive and, well, the performances are pretty good. So the vast majority of people are maybe let's start with the beginning. Let's say that you have established that you need to use a microcontroller board in your project. There are a lot of them on the market. Some of them are original, and others are just clones or derivations from original boards. So obviously the problem that you will have is, okay, which one should you choose and why? Now, of course, the price is always something that is important and will determine, sometimes it will determine if you will want to choose one board or another. However, there are plenty of them that are pretty much at the same price, so obviously you need to be able to choose based on different criteria. The most popular microcontroller boards for many years have been Arduinos, specifically Arduino Uno or Arduino Nano. Of course, there are plenty of others, but I did not choose to buy one from others. I did put Arduino Mega here on this table just for the sake of having a reference point. However, I placed it with a gray color. That's because I haven't actually bought an Arduino Mega board, neither original nor a clone. So I wasn't able to actually perform some of the tests that I will be talking a little bit later. I have placed this on the board, on the table, just so we can compare the specifications, the official specifications, against the others, and have an extra bit of information that might be useful to us. Another popular board, which I believe already has a few years of being present on the market, is Raspberry Pico, which comes right now in different versions, but most notably there are two big versions, one that has Wi-Fi and one that doesn't have Wi-Fi. In my tests I used the Pico that does not have Wi-Fi because I bought them before those with Wi-Fi came on the market. Another board that some people might choose could be AtTiny85. Again, AtTiny is an entire family of microcontrollers and therefore boards, but specifically AtTiny85 is a very small board with probably the weakest microcontroller on the market. I don't know. It has very poor specs, but nevertheless, it is out there. Some people choose to use this kind of board for various projects, and I've seen this board quite a lot on the internet, so I chose to test AtTiny85. Also, I chose to buy several of them back when their price was really low. Nowadays they are more expensive than the others, so anyway, we'll get to that in a moment. And like I said, I have on this table a Ground Studio Carbon S2. Ground Studio is a brand from a company that's here, local to my country. Carbon S2 is just one model of the many models that this company has decided to manufacture. I will not get into very deep details because I made a dedicated video 1 year ago on 23 September 2022. I made a dedicated video called Ground Studio Carbon S2 development board with SAPUT32 S2 microcontroller. I will also put the link to this video in the description. You will be able to find more information in that particular video, including how you can actually use this board in Arduino IDE, what settings do you need to do, etc, etc, and also all sorts of tests that I have made there. In that particular video, I also made a small comparison between this board and the other boards. However, I didn't go into very much details, and besides that, in today's video I come with a little bit of extra information that I didn't had back then. So that being said, let's start and let's discuss the table that we have here. So when we are comparing two or more products, of course, the first thing that we have to do, or the first thing that makes sense to do, is comparing the official specifications of those products, right? So this is what we have here between frequency and ADC depth. So basically on these lines that I'm highlighting now, these are all informations that we get from official manufacturers based on, you know, what components they used for that particular board and what that particular microcontroller is able to do. So when it comes to frequency, Arduinos have 16 megahertz working frequency, all three of them, well, at least Nano, Uno and Mega. A Tiny85 seems to go a bit higher to 20 megahertz, and Raspberry Pico and Ground Studio Carbon S2 are the best when it comes to the frequency of the microcontroller, of the processor of the microcontroller. Raspberry Pico even has a dual core microcontroller that's clocked at 133 megahertz each core. Ground Studio Carbon S2 has a single core that works at 240 megahertz. Now, the frequency is a good indication of how many calculations, or should be a good indication of how powerful that particular processor is, or microcontroller. However, it's not the only thing that determines how many computations per second that microcontroller has. So I've put it on the list just as a reference point, but we will get later to some tests that I've made that show us a lot better, you know, how many calculations per second can each microcontroller actually perform. Flash memory is yet another aspect that we need to care about. Basically, flash is the equivalent of the hard drive of a computer. A microcontroller board does not have flash, does not have a hard drive, sorry, but it has flash, which is the equivalent. The more memory, flash memory we have, the bigger the source code we can write, so the bigger our programs can be embedded into that particular microcontroller board. So obviously, you know, better is more is better. At Tiny85 is a bit problematic with only 6 kilobytes of flash memory. It is extremely easy to just fill that memory. So it's generally difficult to program something at Tiny85, and we will have to use at Tiny85 in very rare occasions when we need just you know, a couple of mathematical calculations, and that's pretty much it. Arduino Nano has 30 kilobytes, Arduino Uno 24 kilobytes, Arduino Mega 248 kilobytes, so a lot better. Ground Studio Carbon S2 128 kilobytes, not bad. It's definitely better than Nano and Uno. And the best in this category is Raspberry Pico with 2 megabytes, so one order of magnitude more than these two ones, and 2 orders of magnitude more than Arduino's. So yeah, in terms of flash memory, if we have long programs, big programs, we might need to use a Pico. In terms of RAM memory, the RAM memory is identical with the RAM of a computer, so it's the memory with which the microcontroller is actively using to store variables and data in memory. Again, at Tiny85 is the worst. It has 512 bytes, not even an entire kilobyte. So yeah, we can only store a few integer or float numbers, and that's pretty much it. Arduino Nano and Uno have 2 kilobytes each. Arduino Mega 8 kilobytes, and the others are a lot better. The Raspberry Pico has 264 kilobytes, and Carbon S2 has 320 kilobytes. Therefore, at this category, Carbon S2 is the best. Now, any microcontroller also needs to have various input-output pins, some of them digital, some of them analogic. In terms of digital input-output pins, as a total number of pins, I have to admit that Arduino Mega is the best here. It has, I mean, this board has 54 input-output pins in total. Next to that, Raspberry Pico is the best at having 26. And then Carbon S2 has 18, Arduino Nano and Uno 14, and at Tiny85 has only 6 pins, because at Tiny85 really has 8 pins in total, so, and 2 of them are the power pins. So yeah, out of these digital input-output pins, the pins that also have pulse width modulation capabilities, well, we have the best board at this category would be Carbon S2 with 18 pins out of all of the digital input-output pins. So basically, each and every digital input-output pin can also have a PWM. Then comes Raspberry Pico with 16 out of 26, and then Arduinos, and at Tiny85 Arduinos have 6 each, and at Tiny85 2 PWM pins. Now, in terms of analogic digital converters, again, Carbon S2 wins at this category with 10 different channels, so 10 different pins can have an analogic reading. Then second place, if we look at Arduino Mega, this is even better with 16 different ADC channels, but besides Arduino Mega, you know, Carbon S2 is the best, followed by Arduino Nano with 8 different pins for ADC channels. Then Arduino Uno, 6 pins, Attiny85, 4 pins, but one of these pins is actually also used sometimes, but especially with the Attiny85 clone boards, so not original boards. One of these pins is also used as a reset pin. So the voltage that we can measure on that particular ADC channel, the voltage range is much more limited. Anyway, I'm just mentioning it so you know about it. And last place is Raspberry Pico with only 3 ADC channels. By far the worst possible option in terms of how many ADC channels do we have. Now, how many channels do we have is not the only thing that matters about an ADC. The number of bits also matters. The more, the better. Attiny85, Arduino Nano, and Arduino Uno have only 10 bits. The same as Arduino Mega, so basically all Arduinos are pretty much the same. Raspberry Pico is better with 12 bits. And Carbon S2 is the best with 13 bits. So basically, if we want higher resolution, if we want, you know, to have more values for our voltage range, we would have to go with a Carbon S2 or a Pico. Also, when it comes to reading the ADC values, the speed matters also. The speed matters as well. And this is, of course, based on what project we're working on, because sometimes we don't care about having many reads per second. Some other times we do care. And in terms of ADC speed, Raspberry Pico is the best by far. Only using Python programming language, we can get at 24,000 samples per second. They say that if you use C programming language, you can actually get a lot more than 24,000. If I remember correctly, somewhere around 500,000, but I'm not 100% sure. Anyway, they say that if you actually use the C programming language, you can have faster access to the ADCs, so you get more readings per second, more samples per second. Okay. Then second place are the Arduinos with 6,000 samples per second. Then Carbon S2 with 4,500 samples per second, and last Attiny85 with 4,000 samples per second. I will show you in a moment how I've tested these things and how I came to these conclusions with these numbers. Okay. Besides testing the ADCs, I also wanted to see exactly how powerful one microcontroller is versus the other when it comes to various operations that, you know, we might want to do on them. So I basically created some loops. In each loop I had the microcontroller calculate some operations, and I divided these operations into 4 categories. One is integer operations, meaning I only calculate things with, and I can actually show you. I have chosen a more or less random formula, mathematical formula, and I am just repeating that formula over and over and over again. I'm calculating that formula over and over and over again for the duration of 1 second. And of course, every time I count how many times, how many cycles I've done, and at the end I know how many of these repetitions per second I have. And these integer operations basically take one integer number, more or less randomly chose as a initial value, and then it calculates this number plus 14. Anyway, I wanted to see if I would calculate addition, multiplication, division, subtraction, and bitwise OR operation with this particular integer number and some integer constants, so that I get to see, you know, around how fast one board is relative to the other. By far the best was Carbon S2 with roughly 560,000 cycles per second. And then came the others, Arduino Nanos with 18,000 cycles per second, and Raspberry Pico with 12,000 cycles per second. This was a bit of a surprise, because you might think that, you know, since the microcontroller runs at 6 times more frequency, you should get, at least relative to Arduinos, you should get a lot more computations per second. For some reason, my results show something else. Now bear in mind that all of these tests were created on only one thread, so I haven't used both threads of the Pico board, just one of them. Of course, if we are to create another thread and run them in parallel, we could essentially double these numbers, or so I would expect. Anyhow, something similar I've done for floating point operations. You know, I'm starting with a floating point variable of a certain number, and then I'm calculating an addition, a multiplication, a division, and a subtraction. Of course, I cannot also use some bitwise operations because they don't make sense on floats. I run these in a loop. I count how many loops I've made in 1 second, and this is the number that I get. Again, Carbon S2 seems to be the best at this thing with 560,000 operations per second, cycles per second of this particular formula. Second place, Raspberry Pico with 25,000 cycles per second, again only for one core. And then Arduino Nanos and Arduino Unos with 18,000 cycles per second. I wasn't able to test at Tiny85 simply because the source code, no matter how small I tried to make him, the source code was just too big too big to fit into this 6 kilobytes of flash memory, and yeah, so I was not able to actually test this way the Tiny85, nor do I care that much. And of course I wasn't able to test Arduino Mega board since I don't actually have one. This is why there is question mark here as well. I also wanted to test trigonometric functions, so again I created another formula that has trigonometric functions, sinus, cosinus, and base 10 logarithm. I also needed some helper functions to convert the degrees to radians, but this is just a multiplication and a division. And essentially I am constantly calculating a sinus, adding it to a cosinus, and then subtracting these from this result number. I'm subtracting a division between base 10 logarithm of the number himself and 0.5. Okay, and of course I'm counting how many times I can do this for 1 second. I'm clocking this and I'm stopping at 1 second, Anyway, this is not the full source code that I'm showing here. I'm just showing you a brief source code just so you can understand what I've done in my tests. And as expected, we have fewer iterations, fewer cycles per second. Carbon S2 was still better than the others at 50,000 cycles per second. Next came Arduinos with 18,000 cycles per second. This one seems to be identical for all three kinds of mathematical calculations with integer, floats, trigonometric. I don't know exactly why. I'm just going to assume that the internal architecture of these kinds of microcontrollers is such that there's not much difference between them. So I'm guessing there's just one unit that calculates everything as opposed to different units that are able to calculate integers, floating points, and trigonometric functions. Anyway, and last place is Raspberry Pi Pico with 7,500 iterations only. I also attempted to establish how fast the memory is of these boards, and to a large degree I failed. I only managed to perform this test on Raspberry Pico, which I guess it's the slowest one of them all, because otherwise I cannot explain, why I was able to perform this test only on a Pico board. What I did essentially is to first create a 500 character buffer. I wrote a star character to all of these 500 positions of this buffer. I measured the time it takes, but that number was only useful for me separately. And then I created another buffer, and I copied the first buffer into this second buffer, and this is what I've basically measured, the time that it took for the first buffer to be written into the second buffer. And based on that, I calculated the speed of this memory copy. If I have 500 bytes that are copied in this amount of time, therefore I have, in this case, 37 kilobytes per second speed of transfer from one buffer to the other. When it comes to Arduino Nano Uno and Carbon S2, the speed was much higher, so I really wasn't able to properly measure the time that it takes. Also, I wasn't able to create larger memory buffers because I just didn't had enough memory. I mean, with the Carbon S2 I might have had, but with the Arduinos not at all. So anyway, memory copy is not so important. It was just something just for fun that I tried to do, but still something interesting nevertheless. So these are the most important specifications and the most important tests that I believe should be done on some boards to compare them. Now again, when it comes to these integer, float, and trigonometric operations, don't take these numbers as absolute values, because again they represent only how many of these particular formulas can be calculated per second. These numbers are only useful to compare them with the same numbers from another board. Okay. Other factors that might come into play, well, these boards are all pretty much the same in terms of what else they can offer. with the exception of Carbon S2 board, which comes with a digital to analogic converter with 2 channels, which is something that I don't really see on the other boards. It also has an accumulator charging, or you might call it battery charging circuit. You can actually use a single cell lithium accumulator, and you can use the USB connector on this particular board to charge that that accumulator. And also you have Wi-Fi integrated into Carbon S2, which is not something that you have on Arduinos at Tiny. It is something that you would get on certain Raspberry Picos, because again, some Raspberry Picos do have Wi-Fi, others don't. If I'm not mistaken, the last version of Arduino, I'm not sure what name it has and what version it is, if I'm not mistaken, they have added Wi-Fi to Arduinos as well. But if we are to just discuss about the classical Arduinos, then they don't have Wi-Fi. In certain projects, you might want to be able to transmit data somehow, somewhere. And of course, there is no Ethernet board, Ethernet connector. So having Wi-Fi will be the only way that you will be able to, you know, take that data from the microcontroller and push it somewhere else. So a board with Wi-Fi in those particular cases will be mandatory, essentially. Okay. So what else can I tell you? Well, the price right now is pretty good for all of them, with the exception of Arduino Mega. So an Arduino Nano, at least here in my country, costs around 5 euros, and it's still the cheapest one. And mind you, I'm not talking about an original Arduino Nano, I'm talking about a compatible board. Okay, so a compatible clone or replica, or however you might want to call that. An original one costs a lot more. Same with Arduino Uno. An Arduino Uno or compatible Arduino Uno costs around 7 euros. An original one costs a lot more. Carbon S2, on the other hand, there's no such thing as compatible ones. These are all originals and they cost 7 euros at this moment. And as you can see, these boards have the most amount of advantages. At Tiny85, in my opinion, they're really not worth anything right now. They have become way too expensive. When I bought them, they were somewhere between 2 and 3 euros. Right now they have reached the incredible price of 8 euros a piece, which is just crazy considering it's an almost unusable microcontroller. This is definitely something that you should not buy. And Raspberry Picos are also good, just like the others. Around 7 euros the option with Wi-Fi, and less than 7 euros the boards that do not have Wi-Fi. Another important information is about energy consumption of these boards. Okay. And this is something that I've tested a little bit more nowadays, and some extra information that I can definitely show you in this particular video that I have not shown you back then. So I have Raspberry Picos without Wi-Fi, and these ones consume about 23 milliamps when they are fully loaded. Okay, same as a Tiny85, 23 milliamps. Arduino Nanos around there, around 20 milliamps, so not a lot less. Arduino Unos sadly consume a lot more. They consume 40 milliamps for some reason. Of course, I do not know how much an Arduino Mega consumes because I don't have such a board. And Ground Studio Carbon S2 is the worst in terms of consumption. However, we need to take into account certain things, like the fact that this board has Wi-Fi. Now, when we activate the Wi-Fi and we push the microcontroller all the way to 100% load, the consumption is around 100 milliamps. So quite a lot, especially if you plan to use this board with a battery or an accumulator or something. However, if you disable the Wi-Fi, and by the way, Wi-Fi tends to be disabled by default. In order to use Wi-Fi, you actually have to include in the source code a certain library and a certain header. Actually, it's not a library per se, but anyway, and actually call some functions to activate Wi-Fi. So if you keep Wi-Fi deactivated, well, consumption can be anywhere between 26 and 42 milliamps, depending on whether the board is doing pretty much nothing at 26 milliamps, or the board has the processor fully loaded 100%, then it will consume around 42 milliamps. Now, regarding the other boards, well, regarding all boards actually, you can actually diminish this consumption a little bit, at least when it comes to Arduino Nanos and Arduino Unos and At-Tiny85 boards, simply because the manufacturers of these boards insisted to place some LEDs that turn on when they are powered on, when the boards are powered on, and also some standard voltage regulators so that you can power your boards from almost whatever voltage you want, not just 5 volts or 3.3 volts. These are components that consume quite a bit of current and for nothing. At least in my opinion, they are for nothing. So let me explain to you what you can do to diminish your consumption. For an At-Tiny85, for example, you can bring down your consumption from 23 milliamps all the way to 16 milliamps by simply removing 2 LEDs and this particular 78L05 linear voltage regulator. This board that you see here is not an original board, it's a clone, a DigiSpark clone. I have a LED here that turns on, you know, when I power the board on. I have this 78L05 voltage regulator that consumes some idle current, and I also have another LED here that for some reason stays on all the time. It's not difficult, it's not all that difficult to take a soldering iron and simply remove these 3 components, okay? And you can gain about 7 milliamps of consumption. Something similar you can do for Arduino Nanos and Arduino Unos. For a Nano you can bring down with 5 milliamps. So from 20 milliamps you can bring down consumption to 15 milliamps. And what you need to do is to remove just 1 LED. On the front of the board you have a power LED, which is actually labeled power, PWR is this one, the third one. If you take a soldering iron you can just desolder him. You can leave the other LEDs because they turn on only in certain cases, like when you plug the USB cable. Otherwise they stay they don't lit, they stay extinguished, turned off. And on the back of the board you also have an AMS 1112 or 1117, I don't remember exactly, linear voltage regulator. Again, so that you can power this entire board from all sorts of voltages from 7 upwards. Well, if in all of these cases we agree to power these boards with exactly 5 volts, exactly how much they need, then we can remove this linear voltage regulator, which also consumes some idle current. So again, in this case, we can reduce the consumption by 5 milliamps. In the case of an ATA85, like I said, we can no longer use the VIN pin because that was the one that was going to the linear regulator. We have to use the 5 volt pin, and of course we have to make sure that we provide exactly 5 volts and not, I don't know, 6, 7 or more, because then we will burn the board. Same thing with Arduino Nano. Normally we might use this pin over here, VIN, which again could be from 7 volts upwards. Well, now we can't use this pin anymore. If we remove this linear voltage regulator, we have to power our board from this particular pin that says plus 5 volts. And again, we need to make sure that there are 5 volts and not a lot more. For an Arduino Uno, Arduino Uno for some reason consumes a lot more current than Arduino Nano, even though they both have the same, as far as I've seen, the same microcontroller, but I believe the other chips on the board consume more for an Arduino Uno. Mainly for 40 milliamps normal, but you can reduce this to 32 milliamps if you remove the same 2 LEDs and one linear voltage regulator. So we have here on the right side a LED that has the text on next to him. We have here on the middle top another LED that has the text L next to him. I have to admit I don't exactly know what that L comes from. And here next to the power input connector we have a voltage regulator. If we remove all 3 of these, then we drop the consumption by 8 milliamps, which is significant, especially if we power these from a battery. Okay, now mind you, this is a picture of an original Arduino from, I believe, the first versions. Different Arduinos, especially the cloned ones, might have different placement for their LEDs and maybe even for the linear voltage regulator. You might have to do a little bit of research for your particular board, you know, to identify these components. But I assure you it's not gonna be a big problem. You don't need to mess around with other LEDs, such as TX, RX, transmission and receive. You can just leave them be. They will not turn on, with the exception of, you know, when there's actual data transferred from the board and to the board. Also, if you remove this voltage regulator, you will no longer be able to use this power socket, this power connector. You will have to supply 5 volts to this pin that says 5 volts here, and you will have to, you know, make sure that there are 5 volts. So whatever voltage regulation you need to do, you'll need to do it outside of this board. However, you do get these benefits of reducing the consumption. Okay, when it comes to Raspberry Pico, you really cannot do anything to reduce the consumption because the Pico does not have a LED that gets turned on and stays on all the time. There is nothing that you can potentially remove from the board to lower the consumption. From the Carbon S2 board, theoretically you could have one LED that is the power LED that stays on all the time. However, in practice you won't be able to remove that LED because every component is so closely put together that it's gonna be pretty much impossible, or extremely hard, and it's not really gonna make much difference. You're gonna free up 5 milliamps of current compared to, I don't know, 40 milliamps or even 100 milliamps. You're not gonna make a lot of economy in terms of current consumption. So in the case of Carbon S2, it really doesn't make sense to do something to lower the consumption. Okay, so that's pretty much it. I hope that these informations are useful to you. I hope that now you can understand better what's the difference between these boards, why you might choose one over the other. As a quick conclusion, what I would say is that you might want to choose Arduino Mega boards if you really need to have a lot of input-output pins, because there's nothing that beats 54 total input-output pins, 16 ADC channels, you know, and yeah. If you have a project in which a single microcontroller board needs to basically control a lot of other peripherals, and you just cannot get satisfied with only 14 or 26, then you will be forced to use something like an Arduino Mega. Other than that, if you can buy Carbon S2s, and no, I'm not sponsored by this particular company. I'm not trying to, you know, make them commercial, but as you can see, Carbon S2 boards, due to their microcontroller, they have some advantages that no other board has. So if you can get Carbon S2 and you are comfortable with whatever limitation this board might have, then this would be the next best choice. Third, but not least, Raspberry Picos are, in my opinion, the last best choice on the market right now. Right now, I really don't see why a person might choose an Arduino, other than a person having already a project created with an Arduino, and that Arduino for some reason got broken, and he does not want to, you know, just recreate the entire project. Yeah, of course, in that case you will buy a replacement Arduino and just replace that board and be done with it. However, when it comes to designing something from scratch, I really don't see the point of using Arduinos anymore. Raspberry Picos are better, Carbon S2s are even better, maybe other similar boards from Ground Studio as well, but this is the cheapest board from them that has these performances. And definitely stay away from Attiny85. They are completely useless. So, unless somebody, you know, just gives you away for free Attiny85s, in which case, yeah, okay, you might, you know, try to do something with them. So, I hope this was useful. I hope that now you have a better image of this entire ecosystem of microcontroller boards. Thank you very much for watching this video. Thank you to my supporters of this project on Patreon. If you would like to support me, the link is down below in the description. Also, I will upload this Excel table that I've shown you in this video on Patreon, so you can download this, so you can have this you know, closer, and you can just check various informations yourself if you need to. Thanks a lot for watching. I will see you soon in next videos, in which I will actually use an Arduino Nano for one of my own particular projects. See you soon. Thanks a lot for watching. Goodbye.